Okay. Now, how to calculate strength of solid plate? The efficiency of joint is the design strength of the bolted joint divided by strength of the solid plate per pitch length into 100. So, strength of solid plate is equal to 0.9 into Fu divided by gamma M1 into pitch into minimum into 0.9 into Fu divided by gamma M1 into pitch into minimum thickness of main plate. Are you getting? See the formula. How to calculate strength of solid plate. So strength of solid plate we can calculate by using this formula. 0.9 into Fu divided by gamma M1 into pitch, that is nothing but P, into minimum thickness of main plate. Now here we can calculate. So here 0.9 into Fu is 410 divided by gamma M1 is 1.25. Now we have calculated pitch. So pitch is the 50 into now minimum thickness of main plate. So we have provided two main plates of having a 12 mm thickness. So here minimum thickness of main plate is 12 mm. Are you getting? So calculate strength of solid plate. We can calculate the strength of solid plate by using this formula. So how much is the strength of solid plate? Please answer me. Hello? Am I audible? Okay. What is answer? Answer is 177 point. Uh,
177.12.
177.12 kilonewton. Correct. 177.12 kilonewton is the strength of solid plate. Now we have to put here the strength of whatever calculated strength of solid plate is there, that we have to put here. And design strength of bolted joint we have already calculated. So now find the efficiency. Efficiency of joint is equal to design strength. What is design strength of the bolted joint? That is value of TDN is the minimum, and strength of solid plate is here we have calculated. So now find out the efficiency and tell me answer. Okay. 750 झेरॉक्स त्यांनी दिल्या का त्याचं पण तेच 750 आणि त्याच्यावर जीएसटी लाव दोन्ही 750. Okay, so efficiency is equal to
37.
design. Okay, 1 minute. design strength of the bolted joint is here. Design strength means we have calculated in step number 6, that is 66.12. So 66.12 divided by this 66.12 divided by 177.2 into 100 is equal to in percentage. Now, how much?
37.33%.
37.
हाँ sir.
37.33. Correct. 37.33% is the efficiency of that joint. It means why 37.33% efficiency is there? Because the due to tension, the plate will carry the minimum load. बघा टेन्शन फेल्युअर मुळे किती घ्यायला लागला 66.12 इतका लोड हा टेन्साइल फेल्युअर मध्ये येतोय. सो ड्यू टू दिस लेस लोड द इफिशियन्सी ऑफ दॅट जॉइंट इज ओनली 37%. Are you getting? If here 98.4 is there, then efficiency will increase. If here 110 is there, then efficiency of joint is whatever strength carried by the joint. It may be due to shear, it may be due to bearing, or it may be due to tensile. Out of these three divided by strength of solid plate, that will be the efficiency. Are you getting? So in this way we can find out the efficiency of the joint. Are you getting? So this is our problem number or example number 3, and we have seen 3 examples on the load carrying capacity of the bolted joint under the type 1, and that 3 examples are sufficient for the type 1. Okay, now we will move towards the type 2. So everyone has written this efficiency. If anyone has not written, please write down how to calculate efficiency. Then we will move towards the next type. Okay. Now, type 2. We have seen the procedure of type 1. So type 1 is the load carrying capacity of the bolted joint, and we have seen the 3 examples of the type 1 with design procedure. Now type 2 is the design of bolted joint. Design of bolted joint. In type 1, we have calculated the load carrying capacity of the bolted joint. Instead of design, we have calculated load carrying capacity. Means in type 1, they have given number of bolts, how many rows that they have given, and in every problem they have given number of bolts. But in type 2, we have to calculate the number of bolts, how much number of bolts are required. In type 1, we have calculated the load carrying capacity. Means butt joint is given, 2 bolts are provided in 1 row, and how much strength can carry these plates or joint, that we have seen in the first type. Now here in the type 2, we have to find out the how much number of bolts required to carry the strength. Means load, how whatever load carrying of the particular joint that given in the problem set. So who has unmute yourself? So please mute. Hello. Please check. Who has unmute? Okay. So okay, I will uh, tell you while writing the procedure. So we will write procedure again one by one, and then we will get how to solve the examples by using this under the type 2. Okay, so write down type 2, design of bolted joint, oblique we can say the connection, bolted joint or connection. Now write down the design procedure here. This is the design procedure, and we have written the procedure in the type 1, that is the load carrying capacity procedure was there. This is the design procedure. So here step 1, see all 4-5 steps are same as the type 1. So step number 1 is same as, but we will write here. Step number 1 is again calculate diameter of bolt hole. Same step. Then step 2, तुम्हाला माहित आहे फॉर्म्युला, त्यामुळे आपण इथं आता लिहिणार नाहीये. We will save the time. Step number 1 is the calculate diameter of bolt hole. Then step number 2 is the calculate pitch and edge distance. Pitch and edge distances. In step number 3, what we have calculated? Step 3. Step 3, calculate design shear strength of bolt. Same as it is, we have to find out. Then in step 4, same, calculate design bearing strength. Calculate design bearing strength of the bolt. Bearing strength of bolt. We have calculated in step number 5. Step number 5 is the again calculate design tensile strength of the plate. And after that, we have calculated step number 6 is the minimum of this 3 strength. Minimum strength of the shear, bearing and tensile. That is the step number 6, and we called the title given for the step number 6 is design strength of the bolted joint. But instead of this step number 6, another we have to calculate, that is the step number 6 is the calculate, this is very important now, calculate number of bolts. Calculate number of bolts. Now, how to calculate number of bolts? Means in this type, the load of the whatever load coming on the joint that is given in the problem statement. म्हणजे या टाइप मध्ये तुम्हाला गिवन डाटा मध्ये काय चेंज असतो तर किती लोड तुमच्या जॉइंट वरती येणार आहे तो लोड तुम्हाला दिलेला असतो. एक्झाम्पल मध्ये आपण काय केलं की एखादा जॉइंट होता त्या जॉइंटची लोड कॅरिंग कॅपॅसिटी फाइंड आउट केली. म्हणजे शिअरिंग मध्ये तो जॉइंट 90 किलोन्यूटन इतका लोड घेतो, बेअरिंग मध्ये तो जॉइंट 98 किलोन्यूटन इतका लोड घेतो, टेन्साइल मध्ये तो जॉइंट 66 किलोन्यूटन इतका लोड घेतो. हे आपण एखादा जॉइंट दिला असेल, नंबर ऑफ पॉइंट्स एक्झिस्टिंग मध्ये काहीतरी नंबर ऑफ बोल्ट्स दिले असतील तर त्याची स्ट्रेंथ किती आहे ते आपण कॅल्क्युलेट केली. पण आता टाइप 2 मध्ये काय करायचं आपल्याला तर त्या जॉइंट वरती येणारा लोड दिलेला असतो. म्हणजे तो जॉइंट 100 किलोन्यूटन इतका, त्या जॉइंट वरती 100 किलोन्यूटन इतका लोड येणार आहे. तर 100 किलोन्यूटन इतका लोड कॅरी करण्यासाठी किती नंबर ऑफ बोल्ट्स बसवावे लागतील. आर यू गेटिंग? पहिल्या टाइप मधला आणि दुसऱ्या टाइप मधला फरक तुम्हाला लक्षात येईल. सो राईट डाऊन फर्स्ट प्रोसिजर, देन वी विल अंडरस्टँड ईच अँड एव्हरीथिंग. Okay, while solving the problem. So here we have to calculate number of bolts. So how to calculate number of bolts? So write down the number of bolts is equal to design factored load divided by see here we can add this our earlier step also as a step number 6. Please go back 1 minute. I will erase this. वन मिनिट. आपण जी लास्ट टाइप मध्ये जी स्टेप नंबर 6 काढली होती तीच याच्या अगोदर कॅल्क्युलेट करूया. what is the step number 6 in last type? Design strength of the joint. So how we have calculated design strength of the joint? Minimum of these three is the design strength of the joint, that we have to calculate, and then we will move towards next step, that is step number 7. Are you getting? Now here we will calculate the number of bolts. So here in step number 7, calculate number of bolts. So here number of bolts is equal to now here one formula is there for the calculation of number of bolts. So number of bolts is equal to design factored load divided by design strength of the joint. See how to calculate number of bolts? This number of bolts is equal to design factored load. म्हणजे त्या जॉइंट वर येणारा लोड हा प्रॉब्लेम स्टेटमेंट मध्ये दिला असेल तुम्हाला, तो लोड इथे येणार. जॉइंट वरती येणारा लोड इथे येणार, डिवाइडेड बाय डिझाइन स्ट्रेंथ ऑफ द जॉइंट. Here we have calculated in step number 6 we have calculated design strength of the joint. Minimum of above 3 is the design strength of the joint. So if we divide the factored load which were given in the problem statement, if we divide this strength we will get the number of joint, number of bolts. So number of bolts in numbers. Why? Because here The upper side load is again in kilonewton, and this design strength of is in kilonewton. So kilonewton get cancelled. So here we will get the number. So that is the number of bolts supposed to provide for this particular joint. Are you getting? So design factored load, that factored load is given in problem statement, and design strength of the joint, that design strength of the joint we have calculated in step number 6. So याचा जर आपण काय केलं कॅल्क्युलेशन केली तर तुम्हाला नंबर ऑफ बोल्ट्स मिळतील, म्हणजे किती नंबर ऑफ बोल्ट्स त्या जॉइंटला बसवावे लागतील, that we will get. Are you getting now what is design and what is load carrying capacity? Load carrying capacity, while calculation of load carrying capacity, एक्झिस्टिंग एखादा जे स्ट्रक्चर आहे तिथं नंबर ऑफ बोल्ट्स तुम्हाला काहीतरी दिलेले असतात आणि त्या नंबर ऑफ बोल्ट्स वरून तुम्ही काय करता, लोड कॅरिंग कॅपॅसिटी फाइंड आउट करता. आणि डिझाइन म्हणजे काय, त्या जॉइंट वरती येणारा तुम्हाला फक्त लोड माहित असतो. फॉर दॅट लोड यू हॅव टू कॅल्क्युलेट दी नंबर ऑफ बोल्ट्स. तेवढा लोड कॅरी करण्यासाठी किती नंबर ऑफ बोल्ट्स बसवावे लागतील, दॅट इज नथिंग बट दी डिझाइन. एखाद्या जॉइंट वरती काहीतरी लोड येतोय, त्या लोड साठी किती नंबर ऑफ बोल्ट्स बसवावे लागतील, दॅट इज नथिंग बट दी डिझाइन. अँड लोड कॅरिंग कॅपॅसिटी इज दी whatever existing joint is there, the bolts are already there, and how much the load will be carried this particular joint, that is the load carrying capacity. Okay, so this is the procedure. So now we will solve the example. Okay, so now example number 1. Example number 1. So write down everyone. Example, write down. Two plates 10 mm thick, 2 plates 10 mm thick are to be jointed. 2 plates 10 mm thick are to be jointed. Am I audible? Please reply.
Yes.
Okay, okay. मला वाटलं मी एकटाच बोलतोय बघ, काय रिस्पॉन्स नाही म्हणून. Okay, 2 plates 10 mm thick are to be jointed by double cover butt joint, double cover butt joint, double cover butt joint, full stop. Design the joint for the following data. Two plates 10 mm thick are to be jointed by double cover butt joint. Design the joint for the following data. Design the joints means we have to calculate number of bolts. That's it. Design the joint means. Now what is data given? Following data. So next line. Small a. Factored design load. Factored design load is given. That load is 750 kilonewton. 750 kilonewton is load coming on this particular joint, double cover butt joint. Then second, Bolt diameter is given. Bolt diameter is equal to, again here 20 mm is given. Then small c, grade of bolt is given. Grade of bolt is equal to 4.6. Then small d, grade of steel is given. Grade of steel is given. That is Fe410. Grade of steel is Fe410. And last, two cover plates, because double cover butt joint is there. So two cover plates, one on each side, one on each side, 8 mm thick. That is given data is there. So factor design load is given 75 kilonewton. Bolt diameter 20 mm is given. Grade of steel, grade of bolt for this joint is 4.6 grade bolt is used. Grade of steel, whatever steel used for the joint is the Fe410 grade steel is used. And two cover plates, one on each side, 8 mm thicks are used. Now we have to solve this example. Okay. Now see solution. So we have to follow the steps. So step number 1, similar to last type, all the above 6 steps are similar to type similar to type 1, and we have to add this one step, that is step number 7, calculation of the number of bolts only. So all 5-6 steps are same, so follow this procedure whatever we have seen in the last type. So step 1 is the calculate diameter of bolt hole. Calculate diameter of bolt hole, that is dh. Now dh is equal to, tell me, d naught plus 2. dh is equal to d naught plus 2. So here d naught they have given 20 plus 2 is equal to 22 mm. This is the step number 1. Okay. Now step 2. Step 2. Calculate pitch and edge distance. Calculate pitch and edge distances. So how to calculate pitch distance? So P is equal to 2.5 into D naught. So 2.5 into D naught is 20 mm. So 2.5 into 20, 50 mm. Step number 1 is calculation of diameter of bolt hole. So we have calculated DH is equal to D naught plus 2. So 22 mm is the diameter of bolt hole. Now step number 2 is the calculate pitch and edge distance. So pitch distance P is equal to 2.5 into D naught. So 2.5 into diameter of nominal diameter of bolt is 20. So the pitch is 50 mm. Again, edge distance. What is formula for the edge distance? 1.5 into DH. So 1.5 into DH is 22. Here we have calculated DH. So DH is 22. So 33 mm is the edge distance. Now, next step, step number 3. So step number 3. So what is step number 3? Calculate design shear strength of the bolt. So VDSB is equal to, if our lecture will stop, because I think within 5 minutes our lecture will be stopped. We will stop again if the lecture will stop, then need not to join again. परत जॉईन होऊ नका. जिथपर्यंत झाले तिथपर्यंत आपण थांबू. मग पुढच्या लेक्चरला बाकीचं करू. म्हणून आता लेफ्ट होऊ नका, अजून 5 मिनिटं आहेत. Okay, so calculate design shear strength of the bolt, that is VDSB. So N into ANB into FUB divided by under root of 3 gamma MB. So please mug up this formula, because this formula is given in IS code, page number 74, I think. Everybody have IS code? You have printed this IS code as I have told. Please print this IS code. जे फॉर्म्युले आहेत ते तुम्हाला तिथे मिळतील. आता मी इथे लिहितोय म्हणून तुम्हाला समोर फॉर्म्युले दिसत आहेत, पण ते तुम्हाला फॉर्म्युला जर लक्षात नाही आला एक्झाम मध्ये तर तुम्हाला तो IS कोड मधून घ्यावा लागेल. आर यू गेटिंग? सो नाउ हियर N is equal to, please tell me number of shear planes. How many number of shear planes will be there? Please read the problem statement. The double cover butt joint is there. Are you getting?
2, sir.
Yes, correct. See, double cover butt joint is there. Main plates having thickness 10 mm and cover plate having thickness 8 mm. So draw the sketch. Now here I will show here bolt, but that number of bolt we have to calculate. For this connection, we have to calculate this, how many number of bolts are required here. So this is the two main plates we have connected by two cover plate. So cover plate having 8 mm thickness and the main plate having 10 mm thick. So now here N is the 2. Why here N is the 2? Because the number of shear planes, here 2 cover plates are there, so that the this joint will be fail in 2 phases. This is one phase and this is another phase. See, I am dark portion, I have here dark portion. So this is the this dark portion is indicating the planes. So this is first plane and this is second plane. So here N is the 2. Are you getting? Everyone, please be with me. Why this 2? Because two number of shear planes are there. The bolt will be fail in 2 portion. This is one portion and this is 2 portion, or this is one phase and this is second phase. बिकॉज ऑफ 3 प्लेट्स आर देअर. त्याच्यामुळं बोल्ट असा 3 याच्यामध्ये फेल होणार. दिस इज फर्स्ट पेज, दिस इज सेकंड. आर यू गेटिंग? सी दिस इमेज. So 2 A and B. So A and B is the 0.78 into 0.78 into pi by 4 into d square 20 square into FUB. How much FUB? 400, because 4.6 grade bolt is given. 4.6 grade bolt is given. From the grade of bolt, we can calculate the ultimate tensile strength of the bolt. So 400 divided by under root of 3 into gamma MB is 1.25. So again here answer is 90.54. Is this correct?
Yes, sir.
Okay. So this is the step number 3. Please draw this figure also.